Nomenclature of alkenes. Alkenes are unsaturated hydrocarbons containing a functional group carbon-carbon double bond, one sigma bond, and one pi bond above and below. Nomenclature of branch chain alkenes. First step, select the longest continuous carbon chain that contains the double bond. So here 1, 2, 3, 4, 5. The longest carbon chain that contains double bond of 5 carbon. So it is pentene, E-N-E named at the back to show that this is alkene. And then number the carbon atom of the parent, giving lowest number at the double bond, not the substituent, at the double bond. So the lowest number at the double bond, we have to start counting the number of carbon from the left. Number 1, number 2. If you give the number 1 from carbon on the right, the double bond will be carbon number 3. So we have to give lowest number at double bond, so start counting from the left. And then name the substituent. We have a methyl at carbon number 4, and then write the name as a single word, 4-methyl-2-pentene. If the double bond is at the same distance from the two ends, begin at the end nearer to the first branch point or first substituent. From the left, you start counting carbon 1, carbon 2 double bond, and then from the right, carbon 1, carbon 2. So same distance from two ends. We have to begin the end nearer to the first branch, means give lower number to the substituent. 1, 2, 3, the substituent will get number 3. From the right, 1, 2, 3, 4. Substituent will get number 4. So your carbon number 1 is here. 1, 2, 3, 4, 5, 6. So carbon number 3 at ethyl, carbon number 2 and carbon number 4 double bond. So double bond, 2 double bonds in the longest carbon chain, you call it di. Di means 2, di-in means 2 double bond. You have to put the number of the double bond 2, 4, means the di is at carbon number 2, carbon number 4, di. In the double bond alkene, named alkene. So this is 3-ethyl 2,4-hexadiene. Not hexene, hexadiene. Hexene if 1 double bond only. 2 double bond, give the number to the both double bond, number 2 and number 4, hexadiene. And then if more than 1 double bonds, like this, hexadiene, and if you have 3 double bond, carbon number 1, carbon number 3, and at carbon number 4, you have 3 double bond at carbon 1, 3, and carbon number 5. So 1, 3, 5 hepta means total number of carbon of the parent. Hepta. Triene means 3 double bond in the parent. So 1, 3, 5 heptatriene. For cycloalkenes, 1 double bond cycloalkene, it must be at carbon 1 and carbon 2. So in this cycloalkene, there is 1 double bond. So that carbon must be carbon 1 and carbon 2. You cannot put at other place. 1 and 2 must be at the double bond. If there is substituent at the double bond, at the 1, 2, the number 1 has to be at the substituent. Here cannot number 1. Number 1 has to be at the substituent. So this cycloalkene's name is 1,5-dimethyl, 1 methyl at carbon 1, methyl at carbon 5, and then cyclopentene. Okay, cyclopentene. You don't need to write the position of the double bond. So just 1,5-dimethyl cyclopentene. If there are 2 double bonds in cycloalkene, give lowest number for both double bonds. So here 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, same, lowest number both double bond. Then don't put this one number 1, number 2, number 3, number 4 because you want to give the lowest number at the substituent. So that's why this carbon is number 1 and 2, because for lowest number for both double bond 1, 2, 3, 4, if you start this one 1, 2, also 3, 4, same. So choose lower number for the substituent. So this name is 2-ethyl 1,3-cyclohexadiene.